Today we'll discuss the alternating voltage and current. So in DC we have seen that the current has remained constant. In the DC the current has remained constant, but in the alternating system the current is alternating after some time. So if the current is varying in such a fashion, it is called as the alternating current. Whether it may be the sinusoidal voltage, it may be the rectangular waveform or the triangular waveform. So these type of the waveforms are known as the uh, sinusoidal waveforms. So today we'll discuss some definition related to the alternating currents waveform. The variation of quantities such as voltage and current with time as shown in above figure. It is called as the waveform. So variation of quantity such as voltage or current with time as shown in figure is called as the waveform. Second is the period. So the duration of one cycle is termed as a its period. Duration of one cycle is termed its period. So in one cycle, how many uh, duration of one cycle is termed as a period. So therefore, the period can be calculated from the duration of one cycles. For examples, we can draw the like this. So this is a one cycle of the waveform. This is one cycle, therefore we can find the period of this. And this is next we'll define another definition. That is a cycle each repetition of variable quantity of a variable quantity such as voltage or current as shown in the above graph is termed a cycle. So this is one cycle and the duration of one cycle is called period. Duration of one cycle is called period. Next is the instantaneous values. Instantaneous value. The magnitude of waveform at any instant in time. This is the magnitude of a waveform at any instant of time. At any instant, the magnitude of a waveform at any instant in time is called instantaneous values. And instantaneous values are generally denoted by the small letters. Instantaneous values are generally denoted by the small letters. Next is the peak value. So maximum instantaneous values measured from its zero value is known as a peak value. So maximum instantaneous value measured from its zero value is known as a peak value. Therefore, we can measure the peak value like this. Suppose this is a waveform of the voltage with time, and this is called the peak voltage. This is called peak voltage, or it is also called as the maximum voltage. Whereas this is called this is called from this peak to this peak, it is called peak to peak voltage, because from one peak to the another peak, this is called as the peak to peak voltage. Or we can show in another words like this, another figure like this. So this is the this peak, this is the another peak. So this is a peak to peak value. So what is peak to peak value? Peak to peak voltage or value. The maximum variation between maximum positive instantaneous values and the maximum negative instantaneous values is the peak to peak value. The maximum variation between the maximum positive instantaneous value and the maximum negative instantaneous value is the peak to peak value. Is the peak to peak value. So the frequency, next is the frequency. The number of cycles that occur in 1 second is termed the frequency. The number of cycles that occur in 1 second is termed the frequency. It is measured in hertz, HERTZ or HZ. It is measured in hertz. So the frequency is generally, it is a reciprocal of time period. Frequency is in hertz and time is in second. Frequency is in hertz, time is in second. So for this waveform, so this is a time period of this, and this time period is 1 millisecond. Okay, now suppose the waveform is like this. This is 1, this is 2, this is second. So this is the actually the number of cycles occurs in 1 second. So this is a time period, 1 millisecond. But the time period for this is generally for 1 cycle. We have to consider 1 cycle. So this is a time period, and which is, what is the time period for this? T is equal to 0.5 millisecond. Time period is for 0.5 millisecond because that is for the one completion of one waveform. Similarly, suppose the waveform is like this: one cycle, another cycle, and like this. So this is the number of cycles that occurs in 1 second. So this is a 1 millisecond. So the number of cycles that occurs in 1 second is, it is one cycle, second cycle and half. Therefore, the time period we have to write for this. What is the time period? So time period is equal to 0.4 millisecond. Time period for this is the 0.4 millisecond. So this is how we can find the frequency and time. Let us take one example. A coil is there, a coil of 100 turns at 1500 revolution per minute in a magnetic field having a uniform density of 0.05 Tesla, the axis of rotation at right angles to the direction of the flux. Okay, the mean area per turn is 40 centimeters square. Calculate, try to calculate number one, frequency, number two, the period, number three, maximum value of generated EMF, maximum value of generated EMF, then maximum value of generated EMF, the value of the generated EMF when the coil has rotated through 30 degree from the position of 0 EMF. Okay, so we'll consider this example. Now see, the coil of 100 turns at 1500 revolution per minute in a magnetic field having a uniform density. Density means it is a flux density. It is given of 0.05 Tesla. The axis of rotation at right angles to the direction of the flux. It is right angles to the direction of the flux. The mean area per turn is 40 centimeter square. Calculate the frequency. So from this we can calculate the given terms. So you know that the solution first is how to find the frequency. So frequency it is the number of cycles per second. According to the definition, what is frequency? It is a number of cycles per second. So it is given in the example. There is a number of revolution per second. Number of revolutions are given. So it is 1500. It is a number of revolutions per second. Cycles is nothing but revolutions. So it is given in the example. It is a 1500 per second means it is a it is given as our frequency is 50 hertz. 50 hertz. So this is coming equal to 30 per seconds. Sorry, here it should be per second. It is a 60 seconds. So it is a 25 hertz. So number of revolution per second. So number of revolutions are given 1500 divided by 60. That is per second. So it is a 25 hertz. Next is second is the period is equal to what is period? That is a time of one cycle. So the period is that is the time is equal to 1 over frequency. We have calculated the frequency. So it is a 0.04 second. Now, what is the expression for the maximum value of generated EMF? Maximum value of generated EMF is equal to EM is equal to 2 pi B A N capital N into sin theta. So what is this B? B is the flux density. This is the area. This N is the number of turns of the coil. N is the number of turns of this coil, and N is the number of revolutions. Number of revolutions. So it is all given, and the angle, the axis of rotation being at right angles. So right angles means first we have to find the maximum value. That is a maximum value of generated EMF. So it is a 2 pi into flux density is given 0.05 into area is given, that is a 4 plus 40 centimeter square, there 0.04 0.004 into number of turns are given 100 into the number of revolutions per second 500 divided by 60. If you solve this is coming equal to 3.14 volt. So this is a maximum generated EMF in the coil. Now the next is we have to find the value of generated EMF when the coil has rotated through angle. So you know that we have to place the coil in the magnets. So magnets are like this. These are supposed to magnets in an S poles having an, and therefore this coil is rotating in this direction. We have to rotate this coil A and B. We have to rotate in this direction. So They are saying that we have to find the value of generated EMF in this coil when the coil has rotated through through 30 degree. Suppose it is like this. This angle is given. It is rotated through 30 degree. So what is theta? Theta is equal to 30 degree. And therefore, we have to put this value. So instantaneous values in this figure, we have the sine theta is equal to, here it is right angles, therefore sine 90 is equal to 1. That's why we have multiplied here 1, because sine theta is there. But in this case, it is given the axis of rotation being at right angles to the direction of the flux. That's why it is of this coil is like this in this direction. Therefore, it is making an angle of 90 degree. And therefore, at that time, maximum flux is cut by the coil, and therefore sine 90 is equal to 1. That's why we have got here like that. But in case 4, the coil is just rotated by 30 degree, so we have to find sine 30. We have to find sine 30, and therefore sine 30 is equal to 0.5, and we have to just multiply this value by 0.5. Then you will get the value of generated EMF when the coil has rotated through 30 degree from the position of 0 EMF. Therefore, answer for the fourth is, this is instantaneous values, therefore 3.14. We are directly writing 3.14 because we have got this values 3.14. Just we have to multiply it by sine theta. Sine theta, which is given, sorry, it is 3.14 sine of 30. So it is a 3.14 into zero point 0.5. This is equal to 1.57. Take another example. Example 2. The alternating voltage equation is given. E is equal to 141.4 sine of 377t. It is given. This is a alternating voltage is given. And we have to find first RMS value. Second, we have to find the frequency. And third, we have to find the instantaneous voltage. Voltage when t is equal to 3 microsecond. Sorry, it is a 3 millisecond. So the equation given with you is like this. Vm, that is maximum voltage, is given. So we have to the instantaneous value. It is generally is instantaneous. The relationship for instantaneous value is V is equal to Vm into sine of omega t, and this equation is the standard equation, and the given equation is V is equal to 141.4 sine of omega t. Where to just this is the instantaneous value E. Instantaneous voltage, which is generally denoted by the small letters. So therefore, instantaneous voltage is given V, and therefore this is a standard form of the equation. Just we have to compare these two equations. Now, if you compare, you will get the this maximum value Vm. So Vm is equal to 141.4 volt, uh, and then the maximum voltage we get, and we have to find the RMS voltage. So V RMS is equal to Vm by root 2. So maximum voltage is 141.4 divided by root 2. We'll get the RMS voltage, that is a 100 volt. So RMS voltage is generally Vm by root 2. So it is 100 volt. And now this is a first solution. Second way to find the frequency. Therefore, we have to also compare these two equations. So it is given. It is a 377. Therefore, if you compare these two equations, omega is equal to 377. Omega is equal to 377. 377, and the unit is radian per second. This is angular velocity, radian per second, and therefore, which is also equal to omega is equal to 2 pi f. So omega is given 377 is equal to 2 pi f, and from this we can find frequency. Therefore, frequency is equal to 377 divided by 2 pi, and this is equal to 60 hertz. This is coming equal to 60 hertz. And third answer, we have to find the instantaneous voltage when time t is equal to 3 milliseconds. So we have to find the instantaneous value, that is means V, and what is the equation? V is equal to Vm sine of omega t. This we have to calculate. So instantaneous voltage V, it is a equation is given sine of 377 t. So we have to substitute here t, which is given, t is equal to 3 millisecond it is given, and therefore after substituting 3 milliseconds we will get the instantaneous value when time t is 3 millisecond. If we put substitute here, we will get 141.4 into sine of 1.131 is equal to 141.4 into 0.904 and this is equal to 127.8 volt. So this is the required answer. Thanks for watching the videos.